Okay, so pre-cal, we created all the polar stuff from just this triangle, X, Y, and R, and theta. So, Sebastian, how would I connect X, R, and theta?
Then just cosine.
Okay, cosine of
Theta.
equals,
X over Y.
so if I cross multiply, X is R times cosine theta. Kyle, how do I connect theta, Y, and R?
Sine theta,
So sine theta equals what?
y over r.
So cross multiply, and R sine theta is the Y value? Okay. Evie, using theta, X, and Y.
Tangent?
Tangent equals what?
Oh, y over x.
Y over X. And what if I don't want theta at all? Ray, how do I connect X, Y, and R?
X squared plus y squared equals r squared.
Pythagorean theorem, okay. So the ones that you need are those. But X and cosine, Y and sine, they go together alphabetical order. Okay, X is R times cosine, Y is R times sine. Right, Cole? You remember this from pre-cal? That fun scintillating stuff? So that was all well and good when R was like 3. Calculus, hate to tell you. R might now be an equation, or not might, it will be an equation. So X is gonna be like crazy business. But it's all good. So again, those equations come from this triangle. Hopefully that's, like, you don't have to memorize it. You can draw the triangle and be like, oh, I need these 3 variables to connect together, and you guys were able to do that. Sine, cosine, tan, inverse, Pythagorean theorem. Just need you to remember polars. There's a pole, the origin, and things radiate out from there. And the coordinates are the radius first and the angle. So this coordinate says facing pi over 2. Okay, I can't touch it. 1, 2, 3, 4. So facing 90 degrees, pi over 2, go up 4 units. It's asking for the rectangular coordinates. Can anyone tell me how to find X, Y? Yeah.
Is it x for cosine pi over 2 and y is for sine pi over 2? So then it's 0, 4.
Which is exactly what we thought it would be, but just confirming, yes, exactly, that's what we did. Okay. And going the other way, if I have a rectangular coordinate, I need an R and a theta. How do I find the R given the X and the Y? Stella, what do I do? How do I find radius when I have the X and the Y? Okay, so what's it gonna be? Square root of 18? Ooh, terrible. How do I get the angle? Maybe?
If you like set up the equation, so like r sine theta equals 3, and then you plug in,
How would I get the angle?
I'm gonna say arc, like arc sine.
Okay, arcsine is complicated. Is there one that, sorry? Arctan. Because I have the x and the y. So tan inverse y over x. Your calculator is going to tell you negative pi over 4. Did I get the angle in the right place? Zach, what's wrong with it? How do I fix it? What's that angle if my calculator is telling me negative pi over 4?
Is 3 pi over 4.
3 pi over 4 is the real angle. So as a polar coordinate, it's radius, comma, angle. All right, and I realize you guys don't remember the pre-cal. However, what if I wanted it to stay as negative pi over 4? Was there something I could do to fix this? Change the radius to negative. So that's saying facing pi over 4, negative pi over 4, walk backwards. Sorry. So you can have negative radius in polars. It means facing this way, go back. All right. Just want you to see how these connect. In rectangular, 1 plus 2 cosine. This is the amplitude of the wave. Goes up 2 and down 2. The vertical shift. The midline is 1. Went up 2. Cosine starts high, ends high, goes in 2 pi. Right? Polar, well, maybe I don't know these at all. Cosine of 0 is 1, so facing 0 degrees, I'm going to go out 3 units. Pi over 2, cosine of pi over 2 is 0, so this is 1 plus 0, so facing pi over 2, go out 1 unit. And then somewhere in there, this is going to equal 0. Cosine equals negative 1/2 at 2 pi over 3 and 4 pi over 3. That's when it's going to hit here. Then at pi, cosine is negative 1 times 2. So we get that in 0 to pi. You don't have to do this for calculus, just trying to show you or remind you that you were able to do this in pre-calc. And generally you get a calculator when you need to do these. Hopefully you know how to put your calculator or Desmos into radian mode. On Desmos, you need to type in the word theta to make the angle appear as theta. And you need to say R equals, and then it'll show up in polar. Okay, that's the 3-minute recap of pre-calc. How y'all doing? Adrian, familiar? Yes, kind of? Okay, and again, you don't need to know these, but just x and cosine go together. So if it's a cosine curve, it's going to wrap around the x-axis. If it's a sine curve, it's going to wrap around the y-axis. And you can make roses out of these things. If it's an even number in there, you're going to get that many petals, sorry, twice as many petals. If it's an odd number, you'll get exactly that number. And limesons, you can get things with dents. If this number is bigger, it's going to have a butthole. Anyway, all right, so on to the calculus. X equals R cosine theta, Y equals R sine theta. Okay, bless you. How would we find dy dx? Anyone got any kind of game plan? Yeah.
Plug in R and then just use product rule.
It says plug in the equation for R. Yes, I agree. So X is gonna equal 3 cosine theta times another cosine theta, so can I just say squared? Yes? And Y is gonna equal 3 cosine theta sine theta? That doesn't really squish up. Okay, that's the first step. In parametrics, how did I find dy dx when things were in terms of t? Evan? Okay, why is my phone ringing? Hello? Cool, in class, how are you? Okay. Yes, he does. I can send it to you. Okay, cool. Correct. Okay. Okay, bye. Okay, the number of times that's run in 25 years would be 4. Now 5. Okay. Okay. I don't even remember what we were doing. dy dx, how am I gonna find that when I got, yeah.
dy d theta over dx theta.
Yeah, okay, so this is going to be ugly. Try it. Find dy d theta, find dx d theta. It's a whole lot of product rule, chain rule, all that business. Ben, you can sit right here. Matthias can sit right here, and Ben, you can sit over there where you can see. Come on over. Did I do that right? dy d theta, 3 cosine times the derivative of sine, which is cosine, plus sine times the derivative of 3 cosine, which is negative 3 sine. And then derivative of x, multiply by the power, lower the power, multiply by the derivative of the stuff inside. Big ol' mess? Okay. And for the most part, for these kinds of questions, I would not simplify from here. They will often say, all right, what is the slope of the tangent line when theta is, see, to pick your favorite unit circle angle? Pi over 4. Lame, but valid. Why is pi over 4 like the cheesy choice? Because sine and cosine are going to be the same. All right. So evaluate that. What is that going to be at pi over 4? What would you get? Sadie, would you get?
Zero.
As the numerators go away, the denominator's not zero, so zero, it's gonna be a horizontal tangent. Okay, so there's a big ugly formula that I will show you in a minute that is memorizing dy dx when you're given polar stuff. Can you guys just remember the x value is our cosine theta, the y value is our sine theta, and then you have to do dy d theta over dx d theta. It's gonna involve product rule. Because the formula memorized is disgusting. There it is. Ew. And they're calling the R F and F prime. But you don't, I hope you don't need that. I hope you know what the product rule is. And in the last example that we just did, the bottom kind of went condensed because it became a square. Okay. Try that out. For that flower, it will not be a horizontal tangent line this time. So it's going to R theta and Y. What trig function connects those three vectors? Sine, cosine, tangent. Okay, so R, unfortunately, pre-cal R was like 4. Now it's that. So what is Y gonna be? Yeah. Okay, gross. The trig function has those guys together. So. everything very methodical. I always write the y equation over the x equation so that I don't turn it upside down by accident. And then doing derivative of that product that I wrote the r, then the other thing, first times the derivative of the second plus second times the derivative of the first. I've already done the work for the derivative of r on the top. I just copied it over. I always think about it again, make sure I didn't make a mistake, but. And again, I would not clean up. I would plug in here. dy dx when theta is pi over 3. Some things are gonna go away or at least become nice. When I plug in pi over 3 to that, sine of 3 times pi over 3 is sine of pi. So did I mess up? Where? Pi over 6, sorry, pi over 6. I lied. Okay, so it's not so easy. 3 times pi over 6, so it's sine of pi over 2. So it's sine of pi over 2. Then times that 2 on the outside, so that's 2 cosine of pi over 6. Root 3 over 2. Sine of pi over 6. Ooh, this was a good one, yeah.
Oh, could you take it out the 2?
Doesn't help me.
Okay. You could cancel it though.
Okay. And here, cosine of 3 times pi over 6, so cosine of pi over 2 is 0. So down here, this second thing is also going to be a 0. So, yes, your 2's are now going to cancel. Sine of 3 times pi over 6, so sine of pi over 2 times 2. And then negative sine pi over 6. What comes out?
Negative root 3.
Negative root 3. Those convenient, nice zeros. And looking at this slope, it was negative, bigger than 1, not hugely bigger than 1. Okay? Yep.
If they were like to ask you for the tangent line, would you then just plug in pi over 6 to y and x?
Yep. So if they wanted the full-on tangent line, let's see. And just a comment, some of you on the quizzes and stuff, you would plug in here and then say equals 1. No, it doesn't equal 1. Plugging in pi over 6, sine of 3 times pi over 6 sine of pi over 2 is 1 times 2 times a half. The y value at pi over 6 is 1. Don't tell me this equals 1. AP will bust you on it, it's called a linkage error. This is all of the y values. You were talking about a specific one, okay? This is root 3. So if you wanted the actual tangent line, y minus the y value is 1, equals slope times x minus the x value. Okay, so polars, the big deal is x is not x is the radius times cosine. Y is not y, it's the radius times sine. And doing the derivative is ugly, but perfectly reasonable. Maybe. Okay. Then there's one more idea. you. Areas of polars. So, it used to be all nice, area under the curve, top minus bottom. How do we do that when it's pi wedges? Well, George, what's the area of a circle equation? Pi r squared. What if I only want a little slice? How do I find, like, if theta was a pi over 3 slice? How would I find it? Yeah.
Theta over 360.
Okay, that's in degrees, so that much
Oh, yeah.
out of, how much of the circle out of the whole circle? So she said theta over 360, that's if theta's in degrees. So angle over 2 pi, if as long as theta's in radians. Well, this is kind of nice. So the area is 1/2 r squared. Cool. What was our last thing we just did with the derivative of? 2 cosine 3 theta? Sine theta? Okay, all right. Fine, we got this. The radius is changing, it's moving. That's how we would find the area of that pi slice, 0 to pi over 3, I don't know, whatever region I wanted. Okay. There's the equation, sorry, it's stupid looking. So that's alpha to beta. And R is some equation for the radius, it's no longer just 4. We gotta be complicated about it. So, find the area of that region, the whole cardioid. Do we know how long it takes to draw that out? Like, we're gonna be integrating from what angle to what angle?
0
Anyone?
to 2 pi.
0 to 2 pi? Okay. Is there symmetry to it? Could I do that tricky thing and cut it in half and go 0 to something halfway? Okay, well, choose your method. Calculator, try it on the calculator. You can be adventurous and do it by hand, it's not worth it.
Miss Pascal,
Yep.
why do you have two on the outside? Oh.
So you asked earlier, could I just take the 2 out? Sometimes it's the radius and you're going to need to square it, so you're really taking a 4 out. So I've made a mistake with it enough that I know. You guys get an answer yet?
18.849.
18.849. Is that, 6 pi? Is it? So that's it by hand, gross. I use tricks. I use pre-cal. To swap out the cosine squared. Cosine 2 theta is 2 cosine squared theta minus 1. We don't expect you to know this. But it's the only way to integrate sine squared or cosine squared. Secant squared, no problem. Tangent squared, I can do that too. But this one is not. But there, we found area. And you could do it with the whole 0 to 2 pi, or you could do 0 to pi and double it. Be careful with the number out front. Pi. Okay, tomorrow we'll have to deal with more complicated things. We still have 5 minutes, so I just want to see, can you guys figure out an equation for, how do you find an equation for that inner loop? What am I gonna integrate over? So this is a thing that you do need to be able to do, and having your calculator is gonna help you a lot. When does that inner loop start? Do I know anything about the angle or the radius? Those are the only 2 things I've got.
Starts at 0.
What is 0?
Like where they intersect.
0 like radians? You mean the angle is 0? Well, when the angle is 0, cosine of 0 is 1. this coordinate is 3, 0, so it's not that. When the radius is 0, so the radius is 3, and then the radius is 1, and then it's getting smaller, when the radius is 0. Okay, so when is that radius 0?
Two pi over 3, 4 pi over 3.
Okay. How would you think? When does the inner loop start? When does the inner loop end? Does the inner loop start 0 to 2 pi over 3? Is it drawn out then, or is it 2 pi over 3 to 4 pi over 3, 4 pi over 3 to 2 pi? What bounds am I gonna integrate over if I want 1/2 r squared d theta? What is gonna tell me that inside loop?
0 to 2 pi over 3.
You guys agree? Michael?
That's 2 pi over 3, 4 pi over
2 pi over 3 to 4 pi over 3? Okay. Because at 0 it's here, and then at pi over 2, and then when it's negative, when the radius became negative, that's making that inside loop. Cosine is negative in quadrant 2, and quadrant 3, it's those guys. There's a symmetry to it, so Cameron, can you tell me another equation that would also work that's a little bit more slick? Because of the symmetry?
Could you
No.
just do pi over 3 to 2 pi?
No. Amelia, what am I looking for?
2 pi over 3 to pi, or pi to 4 pi over 3.
2 pi over 3 to pi, and then I would double it. Because 2 pi over 3 to pi gives me this. Or you could have done pi to 4 pi over 3. It's a small thing, but it might be a thing that's helpful. And some of you are allergic to the multiple choice, because you don't read carefully. They will get you on these. They'll be like, hey, here's 3 different ways I could have found this area. 3 of the equations will be accurate, and they'll be like, which one of them doesn't represent? So you do need to be kind of nimble and think about it. So just warning you. Okay? And tomorrow we will do this. Yay!